everyone and welcome to this video. Kleena here, and today I'm going to take you through the solution to question 10 from this Leaving Cert higher level paper. And this question is based both on statistics and probability, so let's get started. So in this question we're basically told about a race and that there's a number of heats and that the times that it took the runners to complete this race were approximately normally distributed. We're told that there was a mean time of 225 seconds and a standard deviation of 12 seconds. Now question A part 1 asks us to find the percentage of runners in these heats who took more than 240 seconds to run the race. So we're looking for the percentage of X is greater than, so the percentage of runners who took more than 240 seconds. So what we're going to want to do is find a Z-score for this, so then we can find the percentage on the normally distributed curve. So our curve is going to look something like this. So we're going to want to find the Z-score for 240. So how do we do that? We're going to use the standardizing formula, which you can find in page 34 of the log tables. So here on page 34, you can see that you have the standardizing formula, and that is Z is equal to X minus the mean over the standard deviation. So X is the sample in question. This symbol here stands for the mean, and this symbol down here stands for the standard deviation. And Z is of course just our Z score. So our formula was Z is equal to X minus the mean over the standard deviation. So in this question, are looking for X, or my apologies, we have X. X is our sample and X is 240. So 240 seconds minus the mean, and the mean here is 225 seconds all over the standard deviation, and the standard deviation is 12 seconds. So let's pop this into the calculator. So we have 240 minus 225 divided by 12, and that's equal to 1.25. So Z is equal to 1.25. So let's put this on the curve. So here, about in the middle, we have 0. And now Z is equal to 1.25. I'm going to put here. So 1.25. Okay, and I'm going to draw a line up there. So we're asked to find the percentage of runners who took more than 240 seconds to run. So we're actually looking for the percentage here. I'm actually just going to move up this 125 here to give myself a bit more space. I'm just going to redraw the curve. So we'll put 0 here. I'm going to put Z is equal to 1.25 here. So we are looking for the percentage of runners who took more than 240 seconds. So we're looking for this in here. Now, we won't be able to find that directly. What we will be able to find directly from our log tables is this percentage here that is lower than 1.25. But everything under this curve has to equal to 1. So we're going to say 1 minus the purple is going to give us the pink. So let's first of all find what's the purple. So let's go to our log tables. We know that our Z-score is 1.25. So when our Z-score is 1.25, here we have 1.2, 1.21, 1.22, 1.23, 4, and here we have 1.25. So that is 0.8944. So there's 89.44% behind our Z-score. Okay, so I'm going to show you that in here. So the proportion behind the Z-score is 0.8944. So the proportion larger than the Z-score is going to be 1 minus 0.8944. So 1 minus the purple section, 0.8944, is going to equal the pink section, which is what we need. So let me put this into our calculators. 1 minus 0.8944, and the proportion is 0.1056. So that's the proportion in here, but it asks to find the percentage of runners who took more than 240 seconds. So to change this into percentage, we just write it as 10.56%. So to go from a proportion to percentage, just move the decimal place 2 places to the right. Or you could also multiply it by 100. So this is our answer here, 10.56%. And for this question, you're going to get 10 marks. So now for question A part 2, we're told that the 20% of runners with the fastest times qualified for the final. Again, assuming that the race times were normally distributed, so we're using the same curve. Work out the time needed to qualify for the final, correct to the nearest second. So I'm just going to draw my graph and we're going to see exactly what we're looking for here. So because this is a race and we're looking at the race times here are going from fastest down this end to the slowest times. So if you came first in the race, you're going to be here. Came last in the race, you're going to be there. Okay, so that's all I'm saying there. So in this question, we're told that the 20% of runners with the fastest time qualify for the final, and we're asked to work out the time needed to qualify for the final. So we need the Z score required. So the 20% of fastest runners is going to be here. Okay, so we have a Z score, and this is going to be 20% in here. But because our 0 is going to be around here, this Z score is going to be negative. So if we go to our log tables and try to find the Z score with 0.2 underneath it, this isn't possible to work out. So we can't do that directly. What we can do, we can realize that this curve is symmetrical. So there's also going to be a Z here. It's positive. So this is going to have 20% in here. So it also means that this is going to have 80% underneath it. So let's find the Z score with 0.8 underneath it. So let me go to our log tables. So here on page 36, we're dealing with the Z scores. So we're looking for the proportion of 0.8 underneath a certain Z score. So the Z scores are here. So with 0.8 underneath it, so we can see here that the closest one to 0.8 is this, 0.7995. Okay, so that's the closest we can get to 0.8. And what Z score is that? That's 0.84. So our Z score is 0.84. So this Z score here is 0.84. And you'll remember me saying that this Z score is the same, only negative. So the Z score in question is minus 0.84. Now, what we need to find now is the sample time. So we're going to use the same formula we used earlier. And that was Z is equal to the sample minus the mean over the standard deviation. Let's just recall that the mean was 225 and the standard deviation was 12. So we know the Z score is minus 0.84 is equal to X, which is what we're looking for, minus 225 all over 12. So first of all, I'm going to multiply 12 by 0.84. So 12 multiplied by minus 0.84 gives us minus 10.08. And you can say that's equal to X minus 225. So I'm going to move this minus 225 over to the left-hand side. So X is equal to minus 10.08 plus 225. So X is equal to 214.92. Now we can see that it asks us to round it up to the nearest second. But for this question, you can't just round it up to 215. Now, in the marking scheme this year, they allowed it. But just to be careful in case they wouldn't allow it another year, because the time that you require is 214.92 seconds. If you go above that, you're edging into this category here, above the required Z score, okay? Because if you go above 214.92, i.e. if you get 215 seconds. So the nearest second is 214 seconds. That's the nearest second that you will still qualify for the final. So that's our final answer here. And for this question, you are going to get 5 marks. So now question B is more of a probability question. It tells us that Sally takes part in a number of different races in the competition and that the probability that she makes a false start in any given race is 5%. We're asked to find the probability that she makes her false start in her 4th race and to give our answer correct to 4 decimal places. So the probability that she makes her first false start in her 4th race means that she doesn't make a false start in the first 3 races. So it means that the probability that she doesn't make a false start, no FS, false start, is equal to 0.95 and probability of a false start is 0.05 or 5%. So the probability that she makes no false starts in her first 3 races 0.95 and when we say and in probability we think of a multiplication sign, 0.95 in the second race and 0.95 in the third race, and then she makes her first false start in the 4th race, so that's 0.05. So this is 0.95 to the power of 3 multiplied by 0.05, and let's put this into the calculator. So we get an answer of 0.04286, but we're asked to give our answer correct to 4 decimal places, so we're going to round that 8 to a 9, so our answer is 0.0429. So that's our final answer, and for this question you're going to get a total of 5 marks. So now let's move on to question C. So once again in question C we're dealing with probability. We're told that 20 relay teams take part in the competition, and for any particular team the probability that they drop a baton at some point during the competition is 0.1. We're asked to find the probability that at most 2 teams drop the baton during the competition, and again giving our answer correct to 4 decimal places. So what's the probability that at most 2? What are the events that can occur that would fit into this category? So none would drop the baton, or, and again, when we're speaking in terms of probability, when we say or, we think of an addition sign. So the probability of none, or one team drops the baton, or two teams drop the baton. So at most two. So what's the probability that no team drops the baton? So the probability that no team drops the baton, because the probability that they drop the baton is 0.1, the probability that they don't drop is 0.9. So the probability that none of the teams drop the baton is 0.9 to the power of 20. And just to explain that, that means that the first team don't drop the baton, and the second team don't drop the baton, and the third team. So all the way up to the 20th team. So that's 0.9 multiplied by itself 20 times, so 0.9 to the power of 20. I'm just going to get rid of this here. What is the probability that one team drops the baton? So it's 20 teams and one of them drops the baton. So first of all, we're going to do 20 choose one. And then that's going to be 0.1. So there's that chance of that team dropping the baton. And then you're going to multiply 0.9 to the power of 19 this time, because 19 teams don't drop the baton. And now the probability that two teams drop the baton. So there's 20 teams, choose two. So two teams are going to drop the baton. So then you're going to have 0.1 to the power of 2, okay, because two teams, so say if it's team 2 and team 19 drop the baton, so you multiply it by 2, and then you have 0.9 to the power of 18. Now what we're going to do is add these three values together to give us the probability of at most two batons are dropped. So I'm going to put all this into the calculator. So I have 0.9 to the power of 20, or, so I have plus 20 choose 1, and to get the choose button, I'm going to press shift and then the divide button here. So 20 choose 1 multiplied by 0.1 multiplied by 0.9 to the power of 19, or, so again plus button, 20 choose 2 multiplied by 0.1 to the power of 2 multiplied by 0.9 to the power of 18. And this gives us a value of 0.6769. So we have 0.6769, and that's the probability that of most two. So that is our final answer. And for this question, you're going to get 10 marks. Now let's move on to question D, where we're told that 300 runners take part in a road race, and that each runner has a number from 1 to 300 inclusive, and no two runners have the same number. We're told that two runners are picked at random from the runners in this race, and work out the probability that this sum of their numbers is 101, and give our answer as a fraction in its simplest form. So the probability that the sum is 101. So the probability that the sum is 101 is that the sum of them is equal to 101 all over all pairs. Now, how do we find out all pairs? And to do this, we're just going to go 300 choose 2. So of the 300, how many ways can we choose 2? Let's just ask our calculator. So we'll do 300 choose, so shift, divide 2. So there's 44,850 possible ways. So 44,850. Can the sum be equal to 1? So 100 plus 1, or 99 plus 2, or 98 plus 3, all the way down to 51 plus 50. So you can see here that this number goes from 1 to 50. So there's 50 ways that the sum can equal to 101. So equals 50 ways. So the probability that the sum of their numbers is 101 is 50 all over 44,850. And I'm going to work this out in my calculator to simplify it. And that gives us an answer of 1 over 897. And that's the probability that the sum of two random numbers picked is equal to 101. And for this question, you're going to get a total of 5 marks. So now for the final question, question E, you can see here that it's given you a lot of information. So for these questions, I would really recommend that you don't panic when you see all the words and the information, and break it down slowly. So we're told that she ran 2 marathons, okay, the windy and the sunny marathons, so marathon 1 and marathon 2. Tells us that it gives some details on the finishing times for the 2 marathons, and we're told that the finishing times were approximately normally distributed. So her position in each marathon was based on her finishing time. We're told that she came 5,265th in the windy marathon. So 5,264 of the 6,000 runners had a finishing time that was less than Circa's. So this is a very important piece of information. Her finishing time for both marathons was the same. We're asked to use this fact to estimate Circa's position in the sunny marathon. So we're given all the information we need in the windy marathon. to find the time. So let's use the information of the windy marathon to find her time. Then we know that her finishing time was the same in the sunny marathon, and let's use this information to then find her position in the sunny marathon. So first of all, let's find her proportion in the windy marathon. So P, so she was 5265 out of 6,000 runners. So let's work out P here. So 5265 divided by 6,000, and that's 0.8775. Now let's find the Z score based on this P score. So let's go to our log tables for that. So all the P scores are here in the middle, and the Z scores are up along the left side and on top. So the P score we have is 0.8775. So I'm going to round that to 0.88. So which number is closest to 0.88 or 0.775 here, okay? We have 0.87 here, 0.8729, so you can see we're getting closer. Here we have 0.8770. So the number we're looking for is 0.8775, so this is the closest number. So our Z score is 1.16. Because her P score is 0.8775, we worked out her Z score to be 1.16. So now let's use the standardizing formula to find the sample. Okay, and that's going to be her time. So we'll remember it was Z is equal to the sample minus the mean over the standard deviation. So we know what Z is. We know Z is 1.16. That's equal to X, which we're looking for, minus the mean, which was 254 all over the standard deviation, which was 38. So now let's find out what Z is. So I'm going to multiply 1.16 by 38. And I get a time of 44.08, or I get a value of 44.08 is equal to X minus 254. So I'm going to bring this 254 over and add it. So 254. So her time was 298.08. So now we have her time in both marathons. Now let's find her position in the sunny marathon. So how do we do this? We're going to find her Z score in the sunny marathon. So Z is equal to her time, which was 298.08, minus the mean in the sunny marathon, which was 247, divided by the standard deviation in the sunny marathon, which was 29. So let's work out her Z score using our calculator. So 298.08 minus 247 all over 29, and that gives us a Z score of 1.76. So now let's find this in our standardizing curve. So we have 0 here. Here's Circa's Z score. I'm going to put it in here, 1.76. Let's find the percentage of runners who had a faster time than her. So I'm just going to write here, percentage faster than Circa. And I'm going to go to my log tables to find out the percentage that is below 1.76. So we find our Z score, 1.7, and then here 1.76. So go all the way along here. The value beneath it is 0.9608 or 96.08%. So I'm going to put that into my question. We have the proportion lower than 1.76 here, or the percentage faster than Circa, is 0.9608. So 0.9608 of the runners were faster, had a faster time than Circa. How many runners were there? So there were 2,000 runners. So how many of them were faster than her? 2,000 multiplied by 0.9608. Put this into my calculator. So 1,921.6 were faster than her. So they were before Circa. So Circa must have came 1,922nd place. Because of her Z score, we could see that there were 1,921 runners that were faster than her. And again, when we're dealing with times here, it's going from the fastest times to the slowest. So you can see that Circa is nearly one of the slowest times here. So the answer is 1,922nd. And that was her position in the sunny marathon. And I'm just going to fill this into the box that we're given, the table we're given up here, 1,922nd. And for this question, you're going to get a total of 15 marks. Okay guys, so that's all for this question. I hope that you found this video helpful and that it might have cleared up any issues that you had when going through the question yourself. Thank you all very much for listening, and I'll see you all in the next video.